Hello, we're looking at checkpoint 1.20 from section 1.3. Here we're asked to find all solutions to the equation cosine 2 theta is equal to sine theta. All right, we have a sine theta there. The cosine has a double angle, and so what I'm thinking about is taking that double angle and make it into just single angle. And since I already have a sine on the right hand side, I probably would like to express the cosine 2 theta as something with a sine in it. So this is the formula that I'm going to need. The cosine 2 theta has actually three possibilities for their double angle formulas. One involves just the cosine, one involves both the sine and the cosine, and this one involves just the sine. And so this is the one that I am interested in using, and set that equal to the sine. All right, I'll rewrite the equation. We have cosine 2 theta is equal to sine theta, and what I want to do is replace this cosine with 1 minus 2 sine squared theta is equal to sine theta. And once we get that part, I want to bring everything over to one side and treat it like it's a quadratic. And it looks like this has a negative sine squared. I mean, there's a 2 there, but I want to bring that over to the other side to make it positive. And then I'll do a switch. So think about it as a couple of steps, either bringing this to the other side and everything to the right-hand side and switching, or bringing the sine over to the left-hand side and multiplying by -1. So in either case, this is going to be a positive 2 sine squared theta. And so this will remain positive because it stays on that side, or it got brought over with a negative and then became a positive when we switch signs. And then this will change signs into a minus. Okay. So now we have this expression, and if we let x or y, let's let y equal a sine theta, for example, this is going to be 2y squared plus y minus 1. So why don't we do that? Why don't we take it from here, and let's say we do this temporary substitution, and then we will get 2y squared plus y minus 1 equals 0. We can either use the quadratic formula or see if we can factor. I think we can factor this as a 2y and a y, and I think for sure this is going to be 1 and a 1, so that's going to give the 1. Except one will have a positive, one will have a negative. And this looks like this is a positive, which means the one with the 2 would be the positive. That gets multiplied with a 1. So this is a positive. So this must be a negative. All right, any way you do this, do it using quadratic formula if you have to, or I've seen the triangle or the diamond method for factoring, whatever works for you. In any case, this is going to be 2y minus 1 equals 0, or y plus 1 equals 0. Okay, and I think we can do the substitution back and look at this as like a sine again. So let's bring it back over here. And we know that 2 sine theta minus 1 is equal to 0. We'll work that out. And then we also know that sine theta plus 1 equals 0. We'll do them separately, so let's work on this one first. We'll bring this over. That would be a positive 1, and then we'll divide by 2. So sine theta is equal to positive 1 over 2. All right, now we want to know what values of sine will give us a 1/2. Again, going back to the table, sine of 30 degrees or sine of pi over 6 is 1/2. And so we know that at pi over 6, let's draw our angle over here, pi over 6. We know that sine of pi over 6 is going to be 1/2. And this is positive, so it happens in the first quadrant. Where else does it happen? We know that all students, so sine is positive here in the second quadrant as well. So this angle over here, which makes an angle of pi over 6, is also positive. But what is that? This is, we can think about the pi here as 6 pi over 6. And so we subtract pi over 6, we're going to get an angle of 5 pi over 6. So we have pi over 6 or 5 pi over 6. So those are the angles that we're looking at that could be possible solutions. But we also want to have those solutions happen because of the fact that sine is cyclic or is periodic. We know that at every pi over 6 and then add 2 pi to it and then add another 2 pi to it, you're going to keep getting this positive 1/2 for a solution. So we can say we just add 2 pi to it, and people usually like to think about multiplying this by some whole number, n or k or whatever the book uses. So let's say n. So this is 2n pi, and they also say it can go in the negative side as well. So they put a plus or minus n pi, where n is equal to 0, and that will give you pi over 6, 1, and that will give you pi over 6 plus 2 pi, or 2, etc. Okay. We can grab this value of 5 pi over 6 the same way. We'll add a 2, add and subtract 2 n pi, and then again with this criteria for n. Okay, so that's the first part. Now we have this second part where we want the sine of theta is equal to -1. Now -1 sine, if we just look at it, sine is a y value of your point, and the y value of your point becomes -1 down here at 3 pi over 2. So our theta can equal to 3 pi over 2. Or you can go backwards here and say -pi, but in any case, if we add this 2n pi to it, then it'll cover all that stuff as well. So I'll just say 2n pi, or again, n is equal to 0, 1, 2, and also negative, so we'll put a negative here as well. All right. So I think that'll work. So like I said, some people would put 3 pi over 2. Some people would put -pi over 2. That would work also. But by doing this plus or minus 2n pi, you're going to cover the other one if you had chosen one. All right. I hope that makes sense, and I hope that helps. Good luck.